Okay, so we want to graph the system below and write the solutions. And the answer might be no solution or infinitely many solutions. Okay, so here's some graph paper. And remember, to graph an equation, you need 2 points. Okay, you can often have more than 2 points, right, if you want to be sure, but all you really need are 2 points. So what I'm going to graph, let me just color code these. I'm going to graph this one in blue, and I'm going to graph this one in red. Okay, so let's choose for our blue, let's choose x equals 0 because that's a nice thing to choose. So if x equals 0, so what I'm going to get is, let's make a little table. When x is 0, y equals negative 3 times 0 minus 2, y equals negative 2. So let's plot x equals 0, y equals negative 2 in blue. And you need 2 points for a line. So let's choose, I don't know, x equals 2. So when x equals 2, y equals negative 3 times 2 minus 2. So negative 3 times 2 is negative 6. Negative 6 times 2, sorry, negative 6 minus 2 is negative 8. So when x is 2, y is negative 8. So that's going to be a point right here. Okay, and then I want to kind of very carefully draw a line between these points. And you can kind of see, I use just green so I don't, you can kind of see, here, I'll do this, the slope of this line, right? So what's the slope of this line? I went down 3 over 1, down 3 over 1. So if I keep doing that, right, I want to go, okay, I want to kind of go to here. So just one, and then 3 up, over 3, just to kind of make that line. Okay, so now let's do the red one. Okay, so for my red, okay, so let's choose, here's x, here's y. Let's choose x equals 0. When x equals 0, I get 2y equals negative 2. So solving for y, divided both sides by 2, y equals negative 1. So when x equals 0, y equals negative 1. So put a point right there. All right, let's get one more point. How about when x equals, I don't know, 1. All right, when x equals 1, I get 6 plus 2y equals negative 2. So here, this is all part of x equals 1. So I get 2y equals negative 8. So y equals negative 4. So when x equals 1, y equals negative 4. So let's put a dot there at x equals 1, y equals negative 4. And that's going to look like this. And if you notice, right, drawing this line, you actually have the same slope. It's down 3 over 1, right? And then you do it again, down 3 over 1, down 3 over 1, right? And it's going to end up, these two lines are going to be parallel. So over, they're very close, so it's a little bit hard to see. But they're parallel. They have the same slope, and they're never going to cross because, every time, this goes down 3, it goes over 1, but this also goes down 3 and over 1. So they're never going to hit. So they're parallel. So there's no solution. There's no place where these two lines intersect. Okay, so here's another example. So again, I'll do the top one in blue and I'll do the bottom one in red. Okay, so for the top one in blue, let's get a couple of points. So here's x, here's y. Let's do when x is 0, y is negative 2. And we want a nice point, right? I'd rather not plug in x equals 1 because then we get some fractions. Let's plug in x equals 3 so that negative 1/3 times 3 is negative 1. So negative 1/3 times 3 minus 2. So this is negative 1 minus 2 is negative 3. Okay, so let's plot these points. When x is 0, y is negative 2. When x is 3, y is negative 3. Okay, so let's try to draw this, and let's kind of try to continue that same slope. So down 1 over 3, down 1 over 3, going this way over 3, up 1, 3 and 1, 3 and 1. Okay, so that's this line, the blue one. All right, now let's do the red. So for the red, let's get a couple points, x and y. Okay, so let's try, I can actually very easily, well, let's do an x equals 0 first. So an x equals 0, well, then that's just 0 plus y equals 6, so y equals 6. And I could plug in something for x, like I could plug in 1 for x. I could also try just plugging in y equals 0. You don't have to first do x, then do y. You certainly can, but especially when it's set up like this, sometimes it's easier to, pick your y first. It really doesn't matter. I'll pick y first just to show you that you can. So when y equals 0, you get 3x equals 6. So you get x equals 2. So plotting these points, when x equals 0, y equals 6 is there. And when x equals 2, y equals 0 is there. Okay, so let's draw this. Okay, and what was the slope that I had? So notice, let me just use green just to see. I went down 3 over 1. So when I'm down 3 over 1. So when I draw the rest of this, I'm going to be careful about using that same slope. So down 3 over 1 puts me right there. Down 3 over 1 puts me there. I got the important one though. Down 3 over 1. Okay. And so what I noticed is that both of these go through this same point. And what's this point? This point is x equals 3, y equals -3. Okay, and we can double check that this actually makes both of these things true. We already see here when x equals 3, y equals -3. So if we want to check it, we can just check it here. When x equals 3, then I get 3 times 3 plus y equals 6. So I get 9 plus y equals 6. Y equals -3. Right? Or I could plug in x equals 3 and y equals -3 and just make sure that you get the same thing on both sides of the equation.